Okay, good morning class. So today we're looking at quadratic equations and inequalities. I think we're coming to an end of this chapter. So in our last lesson we looked at simultaneous equations. Okay. So today we're going to look at quadratic inequalities, and that's your heading for today. Okay, quadratic inequalities. This is exercise 2.16, and 2.16 is on page. So check. Sorry? 60. Okay, so this is example 1 on page 51. So there's 10 pages between the first example and the exercise. Sorry? That's examples, okay. Okay. So quadratic inequalities. People, we have dealt with inequalities before. We've dealt with the inequalities when it came to primary school work, when they asked you to compare which numbers are greater, and then you had to put the inequality sign in. Not so. Then you came to high school, we spoke about integers, and the inequality came up again. Then in grade 10, you did your number lines. You guys remember? In the first term, we did number lines, and the inequality reading came up again. Okay. So here we're back at it, grade 11 inequalities. Alright. So now we look at quadratic inequalities. What we dealt with before was all linear inequalities. So what does linear mean? The highest power on x in that equation or the expression is 2. And if it's quadratic, the highest exponent x is 2. In linear, the highest exponent x is 1. So we're looking at example 1 on page 51. People, there's many ways of doing this equation. You can do it by graphs. Okay, you can draw the graph first and then take the reading. Or we can use what they call a sine table or a sine line. Okay, but what I've noticed over the years, I used to use the sine table, the sine line. But what I've noticed is the learner understands it better if we draw a parabola. Okay, a function. So what we do is, the first thing we do is we get it into standard form. Okay? So we get it into standard form, which is ax squared plus bx plus c equal to or more than or less than 0. So get it into standard form. So how am I going to get, the question says solve for x where x squared is less than 16. So how do I get that in standard form? I take the 16 over the equal sign. Not so. So that's going to become x squared minus 16 is less than 0. Okay. Now the next point is to factorize. Okay, so I write the factorize, factorize, or I know in South Africa we say with the S, factorize. Okay, to factorize. So let's factorize. What do we get? X plus 4 and x minus 4 is less than 0. Not so. Okay. So now your 0 factor rule. If that was x plus 4 into x minus 4 is equal to 0, what would the critical values be? Sorry? For your 0 values, what would it be? 4. Sorry about that. Would have been 4 and minus 4, not so? Minus 4 and 4. Now note here that I don't say x is equal to minus 4 and x is equal to 4. Why? Because by saying that, I'm saying that those are the solutions. Okay. So at this point, you're always going to see me write the critical values. Now, critical values, if somebody says somebody's in a critical state, what does that mean to say? It's between life and death. Not so? A critical state. So the critical values here is the values in which you are either positive or negative. At that point, it is where it changes. Your zero values or your critical values. Alright? Don't die on us yet. Okay. Maybe after the June exam and so on. Okay. Right. So you guys understand so far, huh? So the next thing is to draw the graph. I'll show you another way after this. Okay? You can decide which way you want to do. But this is the method I'll do. Okay? So we draw a graph. So what type of graph would this be? What type of model would that be? It would be a parabola. It's either you draw a graph of the number line. Eh? I'm using the graph. So she's making some, which is a parabola. How does she write parabola? Because of the square. Not so. On the side here, I draw a parabola. She says the parabola is smiling, not so. And it's cutting your x-axis at 2 points, 2 places. What is your x values here? Negative 4 and negative 4 and 4. So now we read the inequality. Now we look at the inequality. Now we're going to look at the inequality. What does this tell us here? That the parabola must be less than 0. The parabola must be less than 0. What if the inequality had to go that way? Greater than 0. So if something is less than 0, what does it mean? It's negative. If something is more than 0? Okay. So if you look at this graph here, this is the YE is equal to 0 line, not so? That is your x-axis. If something is above the x-axis, we say it is positive. As you can see, the y values are positive there. If it's below, it is negative. So if we're looking at this inequality, we see the inequality says that your parabola must be less than 0. So we're going to look whether the inequality is negative. You all understand? So what I do is I shade where it satisfies the inequality. It is less than 0. It's negative. Okay? If the inequality had to go the other way around, where x is greater than 0, then I would have shaded that part there. So this was above the line, not so. Why wouldn't I shade here? Because that is the less than part there, as you can see. You're with me, no? Okay. So is the solution from minus 4 to 4? Is that continuous? Is it in one? Or is it apart? It's continuous, it's together. So if the inequality is together, or the solution is together, we write the inequalities together. You understand? So if the solution was apart, I would have written the inequalities apart. You guys understand? So we write the following: x has to be that direction greater than negative 4, and x must be less than there's the solution. Something like this worth 4 marks. Okay. You want me to show you the other method? Huh? If you want, you could use the formula there, and then you will go straight into the critical values. Okay? If you can't factorize, good reminder there for us. Just looking at that sum quickly. If you say x squared is less than 16, if I draw this graph, that was the x squared graph. It will be that there. No? We all agree that is the y is equal to x squared graph. No? If x is 1, y is 1. So what we do is 16, we draw a line through 16, y is equal to 16. So what we need to do is we need to find those values there. The x values, okay? So if we find the x values, then we say 16 is equal to x squared, square root, if I introduce square roots plus minus, so x equal to plus minus 4. So this point is minus 4 and 16, and this is 4 and 16. But it says it must be less than 16. So is it above the line of 16 or below the line of 16? It is below. So is that part. Can you see? So x must be greater than negative 4, but x is less than 4. You see how it's longer, no? Otherwise you could have said x squared is less than 16. We take that over, becomes x squared minus 16 is less than 0. You got x minus 4, x plus 4. Your critical values is 4 and minus 1. So these are the sign line work. Okay. The critical values or the zero values is 4 and 4, minus 4. So what you do is you choose a value less than minus 4. Choose any value less than minus 4. Minus 5, nice. So what we do is we say, okay, put it in here. What's minus 5 squared? 25. Minus 16. 9. Is positive or negative? Positive. Can you see that? Choose any value between negative 4 and 4. 0. Nice. 0 squared? 0. Minus 16? Negative. So this answer is negative. Choose any value greater than 4. 5. Nice. 5 squared? 25. Minus 16? 9. Positive. Did you see that? So what do we say here? It must be less than 0. So what does it mean? It must be negative. It has to be negative. So in other words, where is it negative? From minus 4 to 4. Can you see that? Is that continuous or a breaking solution? Continuous. So x must be greater than negative 4. What is it? That's also long, but not so works, and I must test. You see, with us again, the parabola will always be smiled in that form. So we don't have to learn the sign table. We don't need to go check for factors. We don't need, for signs. That's positive and negative. You understand? So that's why I prefer the first method that I showed you. Okay? But if you want to use any of the other two that I've just shown you now, there's no blame on you. You should get the full mark anyway. Okay? This doesn't belong there. Neither does that. Right, let's look at another one. Example 2, and example 2 is on page 53. Am I moving too fast? Okay. Example 2 on page 53. You see now why they have so many pages explaining this? Okay, that is different methods they explain it. Okay. And people, there's a definite question in your grade 12 exam. A definite question. Okay. People, let's look at example 2. It says solve x squared minus x minus 6 is greater than or equal to 0. Where do I start? Get it in standard form. Is it in standard form? Yes. So what's the next thing? Factorize. So factorize this quickly. You can either factorize it using the trinomial formula or the quadratic formula, or you can apply the trinomial. So it's going to be x and x, 3 and 2, minus 3 plus 2. Okay. So what do I write next? Or must I say x is equal to 3 and x equal to minus 2? No, we write our critical values. Critical values are 0 values. What is the critical values? Negative 2, yes, and 3, or 3 and negative 2. People, if you're using the quadratic formula, no problem. You go from there straight into that. Don't force that on that solution into this thing here. Okay, because I see some of over the years some learners try, they get the right values out, and they force it into this into the brackets, and then they get the wrong answer when they solve for x again. Okay, don't keep yourself brave. We know you don't know how to factorize trinomial. It's fine. You use the quadratic formula. Okay. So what do we do now? We take it to the graph. How do I know it's smiling? Because it is positive, not so. If it's not positive, most of the time we make it positive anyway. You'll see later on whether there's a negative, okay? So what goes on the line here? Negative 2 and here? 3. This is y is equal to 0. If it's above the line, it is positive. If it's below the line, it is negative. Okay? So what about this inequality? What do we say here? It has to be more than 0. So what does that mean to say? It must be positive. There it's positive. Can you see that, people? Okay. So what do I do? Do I shade now above the line or below the line? Above. So is that for the? Is the solution together or is the solution apart? Apart. So the solution must be apart. Okay. So what do we say? X negative 2 or x 3. So we say x is in that direction. Are we going in the more than direction or are we going in the less than direction? Less than. So the inequality must be open or close to the x. Okay, let's go here. Read this inequality. X is more than 1. Not so. Let's go here. X is you say 1 is less than x, no problem with that. But we always read it from the variable. X is okay, let's go again. This one? X is more than 1. This one here? X is more than 1. Yes, why? Because it is open to the x. Okay, can you see it? X is more than 1. Right, let's go again. Let's go here. X is less than and equal to negative 1. Okay? And this one here? Equal to negative 1. Right, you guys got it. Let's try now. X is? We go to our left first. X is? Negative 1. And x is? Right, you guys got it, no? Don't lose it now. Right. Coming back here. We have x and minus 2, x and 3. We're going to have or. It must be or. You can't write and here. Eh? It means something else. So x is negative 2. In this direction, is that the more than in the less than direction? Less than. So So we say x is less than negative 2. But there's an equal sign here. So I say less than and equal to. What about this side? X is more than equal to. Easy enough? Yes? Who can tell when must it be apart and when must it be together? If it's in the middle, yes? Together. Why? Because then the solution will be together. You see, if I had shaded that, then the solution would be together. Okay? As you can see, that is apart from that. That's why it's apart. Okay. Anything else? Anybody else want to confuse us? No? Alright, listen. Okay, we'll do another one. So pause the video at this point. I'll give you guys a chance to do this one. It's example 3. And it's on page 55. Right. So where do we start, people? We went with you factorize. Some of you use the quadratic formula, not so? Yes. So 2x times 3 is 6 plus 1 is 7. Both is negative. Okay. Again, if you don't know how to use this, use the quadratic formula. You come out to the critical values, and the critical values are a half and 3. What do we do thereafter? Draw the graph. Which value go here? 3. You all agree with that? Must or half go there? Yes, the number line is closer to 0, she says. 3 is more positive than a half, not so? No? It's moving away more from the 0. Further away from the 0. So what does this inequality say? It has to be, it's open to the x or the parameter. So it is more than 0, which means to say it must be positive. More than 0 means positive. Is the y is equal to 0 line? More than is above. So is that part of the graph? Not so? Girlfriend, is it together or apart? Apart, yes. So that is going that way, and that one's going that way. So what do we say? X has to be in this direction. Okay, we got the half, or x and 3. In this direction, x has to be less than a half, or more than. Do I put the equal sign here? No. Why not? There's no equal sign there. There had to be an equal sign there, I would have put the equal sign there, and on the 3 as well. People, you guys understand? Yes, sir. Any confusion? Alright, you guys stretching, right? You're ready for the next one. No. People, what's the issue here? It is not in standard form. This is example 3 and this is on page 56. Okay. So firstly I must get it in standard form. Alright, so that's going to be now negative 4x squared plus 25 must be greater than or equal to 0. Not so. What do I do now? Before factorizing, take out the negative. Why? Because the first term is negative. So if you take out the negative, divide by negative 1, do that quickly. So it's going to become 4x squared minus 25. Change the signs, less than or equal to 0. So if you did not change the sign, make a note here on the sign. If multiplying or dividing by a negative, then swap the inequality. if you multiply or dividing by negative, you'll swap the inequality. So if it's more than, it becomes less than. If it's less than and equal to, it becomes more than. Okay. So what do I do from here? Factorize. So I'll pause the video again and you do your thing. Right. So what do we do? Difference of two squares. So that gives us 2x, 2x, 5 plus 5 and minus 5. Not so. So what are my critical values? 5 over 2 and negative 5 over 2. So what do I do now? What do I do now? Do I graph? Not so. So what goes on the line? Negative 5 over 2 and why did I draw this as a smiling face? Because this was positive. Can you see that? So what does this inequality tell us? It must be less than. So if it's less than 0, it is negative. Not so. So this is y is equal to 0, that is more than, and this is less than. So do we shade above the line or below the line? Girlfriend, is it a part or continuous? Okay, can you see that? So if it's continuous, I write the x minus 5 and 2, 5 over 2, sorry, negative 5 over 2 and 5 over 2. The inequality will always go in this direction. This here, x is more than negative 5 over 2, and since it's equal, I'm going to put equal as well. Not so. On that side, x must be less than or equal to 5. You guys understand? Any confusion? Let's just wrap the last one up quickly. I know this video is becoming now long. That's not what we want. Okay, so I'm going to go straight into example 5. There's one thing that changes here. It's on page 58. We are told in example 5, solve for x, or solve x squared minus 18x plus 81 is less than or equal to 0. Right, so what we need to do is we need to factorize this first. It is in standard form. If I factorize it, I've noted here that this is actually a perfect square trinomial. Okay. So what's my critical value here? Sorry? X, your critical value is 9. Smiling or frowning parameter? It is smiling. To us it will always be smiling. Ne? We always have a happy outlook on life. Ne? We always try and keep it smiling. It only has one solution. So that is what this parameter is going to look like. Not so. This is the y is equal to 0 line. But what does the inequality say? Where is x less than and equal to 0? Now this part here is your negative. Not so. This is where it is less than 0. Not so? Is there any part of the graph that is less than 0 here? No. But it says equal as well. Is there any part of the graph that says it's equal? Yes. Equal to 0 is there. Not so? So your solution to this is simple. Or simply, x is equal to 9. That's it. So what I'm going to do is I'm going to variate this quickly. What if you got given? What if it was, where is x squared I'm going to use the same so that I don't need to do calculations again. X squared minus 18x plus 81 is more than or equal to 0. I'm going to use the same diagram here. Okay? Where is it? More than or equal to 0. So we're going to look where it is. Positive, not so. There's this part of the graph. What do you notice? It's always positive. And it's equal to 0 then. So here, if that is the case, x is an element of real numbers. That means to say all the values exist for x. Can you see that? What if your dad said, I'm going to do all the variations for you, no? So that you can see a pattern, or some of you won't see anything in here. But it's fine. Where's x squared minus 18x plus 81 greater than 0? So again, we're going to look where it is positive. So that part is greater than 0 and this part is greater than 0. But what happens here? At that point it is equal to 0. Does that satisfy the inequality? No. So here you can say x is an element of all real numbers. X is just not equal to 9. X value of 9. Or you could have said x is less than 9, which is that part, or x is more than 9, which is this part. Can you see that, people? What if they said that was both more than, and equal to? Let's go on the other side. 18x is less than 0. Now 18x plus 81 is less than 0. So same story, not so? So is there any part of the graph less than 0? Is there any part less than 0? No. But what happens here? It is equal to 9, to 0 here. Did I have equal here? No. So what's the answer? No solution. Okay. If you want to look at that again later on, you can. I'll send you the link to the video. Okay. Yes? Sorry? Yes. If you use a quadratic formula here, you'll see that if you put plus the square root of whatever, you'll get 9. If you change that plus to minus, you'll also get 9. Which means to say, there's 2 in one solution. So that is the case where roots are real, rational and equal. So what you can remember, what is delta in this case? When the roots are real, rational and equal. Delta is equal to 0, yes. It's the only time the roots are real, rational and equal. Or whenever roots are equal, it's where delta is equal to 0. Okay. So what I'm going to give you the chance now is to do the exercise 2.16, the first column. I'll go check your books now. Okay, I'll start the video at this point.